Data visualization is essential in data analysis to detect outliers, nonlinear relationships, and other unusual patterns. However, in our context, when we want to explore theory, visualizing problems offers more profound insight into the inner workings of an estimation method. The problem with real data is that reality is imperfect. For instance, we might have measurement errors. The ugly nature of reality does not fit neatly into our theoretical models. To understand and illustrate theory, we need to create a perfect reality. Simulated data is required that behaves exactly as demanded by our model assumptions. Accordingly, we can illustrate the impact of any violations of model assumptions by changing the data generating processes that create our artificial dataset. We start with the usual import statements. The number of observations in line 16 is denoted n. We set this at 1000. The explanatory variable, denoted x, is drawn from a normal distribution with a mean of 0 and a standard deviation of 1. Note that this line creates an array of size n that contains the realizations of the explanatory variable. So these are these 1000 realizations of a normally distributed random variable. It is common to regard a sample of n realizations of an explanatory variable as realizations of a random process, a random variable, such as a normal distribution. This is also called a data generating process. The dependent variable y behaves well and follows a linear relationship with the explanatory variable. Deviations are permitted in the form of an error term u, which refers to realizations of a standard normal distribution. Here we see that we create our error term. Again, that's an array of size n, and our dependent variable follows from a linear model. So we have a constant term of 2, we have a slope coefficient of 0.8, we multiply with our explanatory variable, so we get a straight line, and then we permit some deviations adding the error term. Next, we fit the OLS regression. Before we do that, we add a constant term to our data matrix X. So when we look at our data matrix, we have, of course, our created artificial explanatory variable, and then we simply add a constant to it. And this permits the constant term in our regression model. And then we just estimate that using built-in functions. So this basically is like a black box. And in the following sessions, we explore this black box and dig into the underlying theory. Finally, we do a visualization. This is done in matplotlib. Using standard code, we just add a few labels, we tidy up a bit, and we also save our figure. And here you have it. We have now a scatter plot and we have a linear fit. And it all looks nice, it behaves as expected, and later we can experiment with any violations of model assumptions, and we can see exactly how this affects our theory. I see you in the next one.